Alright, tonight we are going to have our first flipped video lesson. Tomorrow I would like you to give me feedback. Was it easy to understand? Were the guided notes easy to follow? Stuff like that. So be prepared to talk about that tomorrow. In the meantime, let's get started. The definition of absolute value is the distance a number is from zero. There's always, with the exception of zero, there's always two numbers that are any given distance from zero. Say 7. You have the positive 7 on the right, that's 7 units from 0, and you have the negative 7 on the left, but it's also 7 units from 0. So absolute value is talking about the distance a number is from 0. So today in class, and earlier this semester, we worked with absolute value equations. The cause of the two cases we solved with the absolute value equations, we had case number 1 with the number that was a specific number of units from 0, and we have case number 2 where the number that's that same number of units on the right of 0. Now we're going to change the equal sign to an inequality sign. Now we're talking about a range of numbers that meet a specific criteria in the distance they are from 0. They could be at least or at most exactly this far from 0. So we're talking about, if we said 4, it could be less than 4. It could be all these numbers here, but it also could be all these numbers here, because 3, 2, 1 and all the decimals in between, and -1, -2, -3 and all the decimals in between, they're all would be less than 4 units from 0. So we're now talking about a range of numbers. Now, we're going to use the same equation solving skills that we've been using to solve an absolute value inequality. Okay, to solve this one, we need to set up our two cases. So we're going to start over here with case 1. It's going to be the numbers that are on the right of the 0, or it's going to be any value that makes the expression x minus 10 less than 4. Case 2 is going to be the numbers on the left of the 0, anytime the expression x minus 10, and in this case it's got to be greater than -4. And we'll talk about, if you have questions about that, we'll talk about it in class tomorrow. So that's how we set our two cases. If you're comparing this to solving inequalities, remember when we divide or multiply both sides by a negative number, we flip the inequality sign? Well, we're changing that +4 to a -4, so we flip the inequality sign. Now we just have to solve two equations. So we're going to say add 10 here. We've got to add 10 to both sides, right? That -10 and +10 is 0, leaving us x. And we have -4 and 10 gives us 6. Over here, we're going to have to add the 10 to both sides to isolate the x. That leaves us x is less than 14. So if you take this answer and you think about it on a number line, and I'm just going to make a little haphazard one here to help you guys see, we have 6 as one of our boundaries because it has to be bigger than 6, and 14 is our other boundary because it's got to be less than. Now when I graph this one, I'm going to use an open circle. 14 is not included in the answer. Sorry about that. I don't know why I keep doing that. So 14 is an open circle right there. It's like drawing a circle is a secret code for something, it appears. Okay? That's annoying. And then down here, I'm going to draw an open circle, and that thing's going to keep coming back. I don't know why. And our answer is any numbers in between there, right? It does not include 6, and it does not look, I found a way to do it without it making that thing. It doesn't include 14, any numbers in between. And what you want to do is grab an answer to see if you're right. Let's pick 10, because that would be in part of our solution set, right, under this here. If I plugged a 10 in for x, 10 minus 10 is 0, the absolute value of 0 is 0, and that answer 0 is less than 4. That's how you solve absolute value in equations. Alright, now I want you to pause the video and I want you to see if you can solve this inequality on your guided note sheet. It's written out there. Just go ahead, pause the video, solve it, and then we're going to come back and solve it together. Okay, so to solve this video, the first thing we're going to do, to solve this inequality, the first thing we're going to do is set up our two cases. Case 1 is going to be when the expression n minus 2 is less than or equal to 12. Case 2, are you thinking ahead and guessing what it could be? The expression n minus 2, which does not change, is going to be greater than or equal to negative 12. We solved the equation by adding 2 to both sides. That leaves us n is less than or equal to 14. We add 2 to both sides in this equation, and n is greater than or equal to negative 10. Watch your positive and negatives. Negative 12 plus 2 is negative 10. So if you visualize it on a number line, you've got 0 here, you got negative 10 out here somewhere, and 14 down here. What it's saying, and this time it's including 10 as negative 10 is a possible solution, and 14 is a possible solution. There we go with that thing again. It's all these numbers in between, including the two n numbers, right? So when we draw our graph, it would be something like that. Look, 0 is included in the answer, and 0 is a really easy test point. So if I take this 2 and I make it 0, oh, what am I doing? If I make this n 0, 0 minus 2 is negative 2. The absolute value of negative 2 is 2, which is definitely less than or equal to 12, so we're right. Let's try one more. In this one, we're looking for all the values that when divided by 5, they would be more than 5 units from 0. So if you read the expressions before you start solving, sometimes that helps, makes the solving easier. So we're going to start with case 1. And you should be thinking ahead, going, oh, m divided by 5 is going to be greater than 0. And we're going to have case 2, where m divided by 5 is less than negative 5. Remember, we flipped the sign and changed this to the number that's 5 units to the left of 0. Now, are you remembering from first quarter how we solved this equation? Hopefully you are. You're going to multiply, where did I get that from? You're going to multiply both sides by 5. 5 over 5 is 1, leaving us 1m on this side, and it's going to be greater than 25. So if I plug any number in greater than 25, let's say 30, when I divide it by 5, it's going to be more than 5 units from 0. In case 2, I'm going to solve it with using the same thing. I'm going to multiply both sides by 5. That is going to give me 1m on this side less than, look, negative 25. In this particular inequality, the answers did come out to be opposites. So if I took negative 30, which is smaller than negative 25, I would have negative 30 divided by 5. It's negative 6. Absolute value of negative 6 is 6, which it is 6 units from 0, which is more than 5 units. Now, you have 3 more problems on your notes to attempt tonight. We'll practice this in class tomorrow, answer any questions you have, so make sure you make note of areas that you're struggling or things you don't understand, and we will master it tomorrow. So enjoy your evening.